Here we go. For 2-day 1, we are still going to be looking at probability distributions, but we're going to look at a special one out of the 3 that we're going to talk about in this chapter. So the first special one is called a binomial. That's 2. You're going to see where 2 comes up pretty quick. A binomial probability distribution. Distribution. Comes from a binomial probability experiment. And there are 3 characteristics for a binomial probability experiment. The first one is that you repeat the experiment for a fixed number of trials. Repeat the process, experiment, whatever you want to call it, for a fixed number of trials. So you know exactly how many trials you're doing. We're going to be calling that N. On each trial, there's only going to be 2 outcomes, thus the binomial. So there are only 2 outcomes on each trial. You either what? Nope. Nope, nothing to do with drug thing. You'll see in a minute.
Completely wrong.
Yeah. Nope, nothing with the drug thing. The 2 outcomes are success and failure. Success and failure. And then the third thing is that the probability of a success has to be the same on each trial.
Can you chill for 2 seconds?
Nope.
Alright. I was on that.
The probability of success must be the same for each trial.
You capitalize random words.
I know. Trial. Okay, now I'll chill.
Yeah, the word must. Must. Should be all caps. Yeah, but she writes it in all caps.
If all 3 of those are true, then you've got a binomial experiment on your hands.
No, it does not.
Nope. You'll see in a minute what it has to do with when we get to the examples. Okay, the variables that we're going to be working with. I already gave you, okay, we'll call these the N is going to represent the number of trials. P is going to represent the probability of success. Q is going to represent the probability of failure. And X is going to count the number of possible successes. The number of successes that you have. Okay. So I'm going to give you a situation, and then you're going to tell me if it's binomial. If it is binomial, you're going to pick out these 4 variables for me.
That's a Q, right?
That is a Q. P and Q.
It's literate. Why do you Yeah, why do you shout
Okay.
at me?
You are going to take a 10 question
Wanted to make my presence known.
Don't worry, we don't need to.
multiple choice test. Each question has A through E. And you didn't study anything for this test, so you have to guess. Okay? So it's going to be random guesses all the way through. Okay, and we're going to let X be how many you get correct. So a success is going to be getting one correct. Equals a correct answer. All right. Is this a binomial experiment? Let's check. Is the process repeated for a fixed number of trials? Do I know how many trials I'm doing?
Yep.
How many am I doing? 10. Each time I answer a question, that's a trial. So I know I'm doing 10 trials. Are there only 2 outcomes each time?
Yes.
Either, what happens?
You get it wrong or you get it right.
I get it right or I get it wrong. Success and failure. Success, I get it right. Wrong, so failure. Okay? Is the probability of success the same on each trial? Is it the same for each question?
Well, it should be.
It should be because they're all A through E. If I had some that were A through E and some that were true and false, then it's not binomial. Because a true and false, what's the probability of success on a true and false? 1/2, 50-50. On an A through E, what's my probability of success? 1/5. So because they're all A through E, my probability of success is the same. So this, yes, it is binomial. Now you have to be able to pick out N, P, Q, and X.
N equals 10.
N equals 10, that's the number of trials I'm doing. P is the probability of success. What's the probability that I guess the correct answer?
1 out of 5.
1 out of 5. What's the probability of failure?
4 out of 5.
4 out of 5.
No.
And then X is the number of successes. I've got a range of values here. How many could I get right to how few could I get right? 0 through 10. I might guess all of them wrong. All the way through guessing all 10 correct. So X can take on any value 0 through 10.
Would we get in trouble if we just put 0-10?
That's fine. But now we're going to be able to say, well, what's the probability that I guess 2 of these correct? Or what's the probability that I get more than 7 correct? We're leading into that kind of probability stuff. So we've got a formula for that. So we're going to do by hand, and then the program, that by hand formula is built into a program, so we'll do them 2 ways again.
Calculator's so fancy.
So the binomial probability formula for X successes P of X. X is going to represent how many successes I have out of my trials. To get this probability, it's a little plug and chug. NCX, that's our combination button. Remember back in advanced algebra when you did the NCR and the NPR? This is that C button. Okay. Multiplied by
The worst thing on the earth.
P to the X multiplied by, I don't know if I like that, maybe I'll do parentheses, multiplied by Q to the N minus X. This is your by hand formula. This formula is built in, and I'll show it to you after we go through a by hand one. There's going to be a lot of questions that deal with a deck of cards, so there's usually people that have never played cards, which just amazes me. So before we get to the problem, I think we need to review what's in a deck of cards so everybody knows. You know what's in a deck of cards, Haley?
52 cards.
52 cards, all right.
And nobody else knows the jokers.
Let's see, a deck of cards.
That is your opinion.
It's alright, Austin, I'm with you.
Okay, there's 52 cards.
You're on my side. What is it?
This is an explanation of a deck of cards
I just chose Austin.
before we get to an example. Okay, what's the 52 cards made up of?
4 of each.
4 of each what? What are we talking each? 4 suits. There are hearts. What numbers are the hearts? What cards do we have in a deck of cards?
Four of
One
them.
through 10 is Jack.
Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Jack, Queen, King.
Jack, Queen, King. So it's ace through 10, Jack, Queen,
Heart thing.
King. So how many heart cards are there? 13. Okay? You've got the same cards in 3 of the other suits. What are the other suits?
The clover.
Club.
Oh.
There's the club. Same thing, ditto that. So there's 13 clubs. What's another one?
The arrow.
The spade.
Oh my god.
Upside down heart with a little tail. Spade. 13 of those.
Diamonds.
And then the diamonds.
6.
And then 13 of those.
Clover.
Okay? And then there's 2 colors. Which ones are the black ones?
Black and red.
Black and red.
Black and yellow. Spade and club.
A spade and club are black. The other 2 are reds. Okay. So, there's a deck of cards. Like I said, there's going to be lots of different questions through the book that deal with the deck of cards, so everybody knows now.
Why cards though?
Because they're easy to do probability questions with. Not that anybody sits and does that, but...
Sorry, we're not.
Oh, except for the, what's that poker they play on TV, because they always put the probability up. Texas Hold'em.
The shows are so funny because you got people with like backwards hats and like oh.
Yeah.
Hilarious, actually.
Okay. We've got a deck of cards.
Pro poker, that you're pretty badass because you're getting paid to play cards.
You're going to pick a card
Take money,
Even if you
exactly.
didn't take last class.
I'd wear my hat backwards for that.
5 times
Gold chain.
Exactly.
Wow, okay, nobody did.
with replacement. So we're going to pick a card, look at it, put it back, shuffle, pick a card, look at it, put it back. So every time I'm still picking from a full deck. Nope.
I'm running.
With replacement. Can you find the probability of picking 3 club cards? Not the 3 of clubs, but 3 out of the 5 that you pick are clubs. Yep. Okay. So all we need to know are our 4 things. N, P, Q, X, we can plug into our formula. All this is plug and chug math. So, what is our N in this situation? How many trials am I doing? 5 trials. Picking a card is a trial. Pick a card, look at it. So N is 5. What's the probability of success? What's considered a success for my question?
Getting a club.
Getting a club. Do I have a club in my hand or not? So club is a success. Anything else is a failure. What's the probability of picking out a club?
3 out of 5?
What fraction of the deck is clubs?
13 out of
13 out of 52, or it's 1/4, because all of these are equal. So it's 1/4 of the deck. Are we good there? Yep, 13 out of 52 reduces down to 1/4. So what's the probability of failure then? Failure would be getting a heart, a spade, or a diamond.
3/4.
3/4.
But wouldn't it change every time you picked a card?
But I'm putting it back in with replacement. Otherwise, yes, this would not be binomial. If I kept the card each time, then it's not binomial because my probability is changing with each trial. Yeah. And then what's my X? How many successes am I looking for? I'm looking for exactly 3 successes out of the 5.
You want to put 3 over 5?
No, no. X is the number of successes. So, now I just use these numbers and plug into that formula that I gave you at the top of the paper. So it's NCX. What's my N was 5, C3, times P. P is 1/4 or 0.25. I'm going to go with 0.25. Raised to the 3rd. Q is 0.75. You can put the fraction, it doesn't matter. Raised to the, what's N minus X going to be? 2. So are you okay with that if I just put a 2 in there?
Yep.
Everybody knows where I got these numbers, you can just copy them down? I should have said the probability of 3 successes equal. And now it's calculator work. So, let me refresh your memory where this C is at. The scientific calculators have that stuff too. Okay, on mine, I have to put the 5 in before I go grab the C. I don't know if the newer operating systems do that or not, but just follow along and see if it does. So I'm going to put my 5 in first. Now I'm going to go grab that NCR button, and it's under Math, right over here, Math, over to Probability, and then you'll see it right there at number 3. And now I need to give it the R, which is a 3. So there's my 5, choose 3, times 0.25 raised to the third, times 0.75 raised to the second. So what is this probability?
Yeah, 0.087.
I have 0.068.
I got 0.879.
I got
get
error,
exactly what you
so
got.
I clearly did not.
0.08.
0.08.
Matt's going to try it again.
I got it.
You got it now? Anybody else not get it? You can find NCR on your own? Oh, it's down there. Okay. Can I get rid of this?
That's the answer.
That's the answer. It's the probability. It's just formulas.
That was they'll be good or bad.
8% chance of picking out. That's not very good. What?
What's the NPR used for?
NPR
Yeah.
instead of NCR?
Yeah.
The P was like counting how many ways to line things up, where NCR was how many ways to grab a group of something, where the order didn't matter. Okay, now we're going to make a binomial probability distribution.
Let's take up as much space as the last probability formula.
No, there's no formula here. This is just a definition. This thing is a table.
Wait, is it just a definition?
Correct.
Whole weighted average.
That shows all possible X values and their probabilities.
That sounds awful.
I'll say P of X is for probabilities. I'll make it a short one. We won't ask 7, we'll ask 4 people. Okay, here's our next situation. A study was done that shows 71%.
Where's this example 3?
Oh, 3. Oh yeah, I do have a 3 on my paper. 71% of retired workers rely on Social Security to survive.
I like how the teachers are like, their education, so I think
That's right. Oh, well, I try my best, Austin.
No, I
Oh, you're not slamming me? Okay.
Not here, thanks.
Okay. Okay. We're going to randomly ask 4 retired people. And we're going to ask them the question, do you rely on Social Security? Okay. Make a probability distribution for the ones that say, yes, I rely on Social Security. So before we can make our table, well, we'll make it in a minute, I want to pick out the N, P, Q, and X. All right. N, how many trials am I doing? 4 trials. I'm talking to 4 people and asking them, do you rely on Social Security? Do you need it to survive? What's the probability of success?
4 out of 4.
71.
71% of them. 71% of the population is known to rely on Social Security. There's my probability of success.
Huh.
What's the probability of failure then? How do I figure that out?
0.29.
Yeah, you take off of 100%. Success and failure have to add up to 100%. X, how many I didn't ask for a specific one because I'm making the distribution. So how many could say I rely on Social Security? What's my range of values? 0 through all 4 saying. So there could be none of the 4 people that I pick through all 4 saying I rely on Social Security. So there's my table. There's my X value for my table. So X could take on a value of 0, 1, 2, 3, and 4. And now I've just got to find those probabilities. It's 5 problems in 1. I'm going to let's do one by hand, and then I'm going to show you the program. Okay, so let's just practice the formula again. It's N, which is 4. Let's do the 0 by hand. What goes on the other side of the C?
Can you move it up?
Yep.
0.
The 0, the X value. Then we're going to multiply by P. What's P? 0.71 raised to the formula say X.
4. Oh, 0.
0 we're doing. Times Q, which is 0.29, raised to the, it's N minus X, correct? So it's 4 minus 0, which is 4. So I would definitely write the formula on top of your paper today so you've got it. So you don't have to keep flipping back. Just quickly write it up there. So we'll run through this. And I want to show you a little trick. Can we? Yeah. If you can re-enter your line. If I hit second entry, it retypes my line. And then I can just type over some numbers. Like if I was to keep doing this 5 times, but I want new numbers anyway because I got the 0.71, the 0.29. But so I'm going to start over. So 4, math, over to probability, NCR, 0, 0.71 to the 0, squared. Oh, not squared, 4.
It's a 4.
To the 4. I got it.
I just want to make sure.
I was wrong. So what's our probability here?
I don't know, press enter.
0.00707. The book, very inconsistent how many places. They usually, once they get a non-zero digit, they'll put 3, 2 after that, usually. If you put 0.007, am I going to mark it wrong? No. Okay, so where is this formula at on the calculator? I will show you. You're going to go under, and I'll show you in a minute after we write it down. You're going to go, let's see, program. We'll call this the program. Go all caps for Kenley.
Is this like a long thing? Yeah.
Nope. 3. You're going to go under distributions, DISTR. You're going to go down and look for binom PDF. That stands for binomial probability distribution function. I will show you. You're just writing down right now. In this program, you're going to feed it some values. You need to feed it N first. Then you need to feed it the P value, the probability of success. Then you need to feed it how many successes you want. And then the programmers have built in that NCR, blah, 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 right in there, and it goes through and does it all. So, is the distribution at?
So we're not supposed to put Q in it?
Nope, because it can figure out Q, because it's 1 minus, so it's smart enough to figure that out and built in.
Oh,
Distribution's right here in yellow on mine, it's yellow above the bar key. Right here, can you see it? And it's way down, I'm pretty sure it's way down for binom. Okay, be careful, there's 2 binomes here.
You don't even have to hit program.
No, I'm just telling you, this is the program that's coming.
Oh.
No, yeah, don't hit, oh, maybe I shouldn't do that. I should say the program.
Wait,
The program versus by hand. So I want you to pay attention here. There's binom PDF and binom CDF. Tomorrow you're going to learn about the CDF, but today make sure you're grabbing the right one. It's number 10 on mine. It's 10. Is it 10 on the new ones?
Yeah.
I'm 8.
You're on 8? No?
Mine's 11. 8. No, 8.
Oh. Oh, A. So you got one more up there that I don't have. So make sure you're on binom. Are you on PDF and not CDF?
Yeah.
Okay. All right. So let's do the 1. The 1 success. So N was 4, comma.
Mine's like trials. Mine says trials P.
Well, there you go. Don't hurt yourself. How many trials are we doing?
Don't hurt yourself.
What's the P? It's almost easier because they're telling you what to put in. Where the old one, you got to know what order to put them in.
Don't hurt yourself. How
Yeah.
many trials are you?
Well, we already got that answer. I would put 0 and I'd try the 1.
Just kidding. Maybe we'll get the 4th one.
0.71, comma, and I'd like to know what's the probability of getting 1 success here. So enter. I can go second entry and just go back and type over the 1 and put in a 2. A second enter. It gives you the entry right above.
I 100% did not get .254.
For a 2,
Never mind.
I'm on 4.
You bring it down.
Well, you should be doing these.
Well, I did do them, I just wanted to
Okay.
do it correct.
See, I'm going to use the shortcut now. I'm just going to go second,
Ooh.
enter, and it retypes the line. I can back up and now change my 2 to a 3.
I feel like honestly my fancy calculators can't do that.
Oh, true.
And then one more time.
Okay, so mine. Yeah, we still can. Sweet.
Wait, are you just doing it like the old way? Like people with the new. Okay.
Okay.
Okay, so those are my answers. I have that, so I did entry.
I know how to do it.
4.71, comma. Yeah, you're good there. Go over. Change your 1.
I got 254 for 4.
Oh, no. The trials aren't changing. 4 trials. The X is on the end, Austin. That's the number you want to change.
I would hopefully last.
No. Let me look. I just had one more just doing nothing new. Are you good?
We're good.
Yeah, we
Okay.
understand it.
All right.
Bathroom, no?
Yep. So your assignment is going to be
Wait, I need to see that table.
page. I'm not sure of the page number.
Okay.
3 through
How do you know
6.
the question?
Because I have them written down here. 7 through 12, Part A only. 13, A, C, D, and E. C, D, and E is going to ask you to find the mean, variance, and standard deviation. You're going to do this like you did yesterday with the 1-var stats. And I want to practice. Let's go with, it doesn't matter, odds by program, evens by hand. Which one would you rather check in the back? Probably the hand one.
Yeah.
Yeah.
So we'll go odds by hand, odds by hand,
Like the 7 to 12 thing?
yep, and then the evens with a program.
Just for 7 through 12, right?
Yep, just for the 7 through 12. 13, I would just do the program, because there's like, you gotta make the whole table.
What about 3 through 6?
That's wordy questions.
What is that? 7 through
So-
12 is some?
The odds by hand and the evens by program, the 2 ways we did it.
So it's 12 part A.
12 part A only. Okay, we're good.
pages it's on?
I'm not sure.